Welcome, everyone.
Well, good afternoon, everybody, and I'm delighted that you've joined us. This is a very important series of presentations from experts, and we've got another today whom I'll introduce in a moment. The issue is the development of national and regional action plans for Africa as a whole, but our focus is on the Abidjan Convention countries, and we're trying to have more people representing the Abidjan Convention than we have at the moment. So the next discussions are going to be more in French than they are, and so we'll have to listen to the translators rather than this time. We've had a really good series so far, as I said, with excellent speakers and wonderful contributions, all of which, as Tara mentioned, are being recorded, and all of which will be available to you and summarized at the end as well. The session was kicked off by Abu Bamba, who heads the Abidjan Convention, and that was really good because he provided a superb context, and the context was also added to by Professor Linda Godfrey, who was actually a senior author in the development of the African Waste Outlook, Waste Management Outlook, and that set it going. And then we began to look at the different aspects that are really important within the series. And the whole series is structured so that we can begin to initially look at the problems, then begin to look at different solutions and to better understand the plastics industry. And then last week we moved on to the economics aspects, having a look at extended producer responsibility, that was by David Drew, and then the final one on Thursday last week was by Professor Reza Daniels, who in fact spoke about the economic aspect because he comes from the University of Cape Town School of Economics. And again, this is fundamentally important because decision makers are driven to a very large extent by the economics of the issues. And if we can place things within an economic context, so much the better for going forwards. So really, that's great. Now, today, we have Selma who's joining us, and she's going to be now looking at, well, how do we deal with some of the issues? We've touched on many occasions, the issues of recycling and the need for this and the need for the enterprises that have it, because that provides the incentives for people to take their plastics and to sell it. But you can only do that with recyclable plastics. So what does one do with the non-recyclable plastics? And this is where Selma is going to be coming in to talk to us, because she is actually working within the Abidjan Convention in Ghana, in fact, in Africa, and she's representing the Plastics Revolution Foundation. And what they're doing is looking at chemical recycling, which can virtually take any plastics and convert them into something useful, which can be a marketable product and feed into the economies, which need, therefore, to be part of the action plans that we consider for the Abidjan Convention countries and other countries in Africa. So, Selma, thank you very much indeed. We are delighted to have you, and we are very pleased that you're going to be speaking in English because we have translators for that. If we'd been speaking in Norwegian, we would have struggled a bit more. But thank you very much indeed, and very welcome. Over to you.
Thank you for having me. I'm very excited about speaking on this topic because it's really very close to my heart, both the issue of plastic waste in general, but also how to develop commercially viable solutions to plastic waste, because I and the foundation that I work for profoundly believe that this is one of the only ways in which you can develop really large-scale replicable solutions to plastic waste. There's only so much you can do on sort of on an aid or on a voluntary basis. To just start out very briefly, and sorry to those of you who attended the session last week, a couple of slides are the same. But I just wanted to start out with setting the stage in recognizing that plastic is an amazing fabric. It's durable, it's waterproof, it's affordable, flexible, light and strong, and it has revolutionized production and consumption within so many areas. Last exemplified by the COVID crisis, where we use plastics as face masks, hindering the spread of infection, but at the same time causing a large new environmental problem. The challenge of plastics really lies in how we use and discard it. Packaging is used for the least time and is often the most difficult to recycle. Still, it's the largest single category of plastic waste that we produce. This is a huge issue and has to be addressed in developing a more circular economy and solutions to waste as in general. Plastic pollution is an exponential issue that requires multifaceted solutions. Every year, we produce hundreds of millions of tons of plastic. 15 tons is estimated to leak into the ocean per minute. There's a recent report that came out last year called Breaking the Plastics Wave, where the Pew Charitable Trusts and Systemic modeled how much they assumed would leak into the oceans by the year 2040 in the absence of any preventing measures. And the estimate that the amount that leaked into the ocean in 2016 will actually triple. So we have a huge problem on our hands. It's a problem that doesn't go away. Plastics do not easily biodegrade, and duration estimates range from 450 years to never. This means that all plastics that has ever leaked into the environment is still there in one form or another. It breaks into small pieces, which we're only starting to learn about the effect of eating as it enters the human food chain. While the problem is concrete in the sense that we need to get better at the way we use plastics, stop putting it into nature, and be able to clean up some of what is already there. It sounds like quite sort of a simple problem to solve, but solutions are quite complex and lie in the interplay between technological, social, and political and business factors, because it really comes down to how we utilize resources and changing the way that we produce things from being linear to becoming more circular. Plastic pollution is particularly urgent in low and middle income countries. This is because the problem is of great environmental, economic, sanitary, and social urgency. Although we also consume huge amounts of plastics in the European Union, in Norway, among others, we have better waste management systems. So the plastic tends to not leak into nature. So in that sense, the problem is somewhat different. The inherent issue of better resource utilization remains, but when it comes to the environmental issue of plastics leaking into the ocean, it's really quite centered in especially middle-income countries where most of the leakage happens. The Plastic Revolution Foundation is founded on a commitment to combat global plastic pollution in an economically sustainable way. It was founded by the industrialist Kjell Inge Røkke and is led by Erik Solheim, who is a former Norwegian Minister of Environment and also former head of the UN Environmental Program. Our first project is to investigate the possibility of building a pyrolysis plant, and I'll go back to what that is, in Accra that is capable of converting plastic waste to fuel or feedstock for new plastic in a way that is self-financing. Before I move much more into the Accra project, I'm going to spend more or less the first half of this talk on chemical recycling as a sort of technology category and go into some of the potential and also the challenges of this type of solution. Chemical recycling. In order to understand chemical recycling, it's necessary to gain a better understanding of what plastics actually are. Plastics don't exist in a natural state or are obtained thanks to chemistry and polymerization. But plastics isn't just plastic. If you look at the bar to the right, you can see the 7 main types of plastics, or one of the types is other, so it's sort of a broad category. But the main categories of plastics that you will see if you consume water and look at the bottom of the bottle, it will have this little, most places it will have this little mark where it says a number in the middle. If it says 1, that means that it's PET, as you can see on the top. Then you have other types of rigid plastics, such as HDPE and PP, that will often be, containers for medicine, for milk, for shampoo, and so forth. You also have PVC, which is commonly found in pipes. You'll have low density types of plastic, which is what we would normally call film. You have polystyrene, which is commonly seen in sort of daily goods in its expanded form, which is called styrofoam in the US. It's called isopor in Norwegian. And it's also what you see in Accra when you get these sort of, you can see the picture as well, this takeaway container that you get food from on the street. That tends to be expanded polystyrene. And these are just some of the plastic types that exist. And the reason I'm bringing this up is because all these types of plastics have different chemical structures. This is one of the reasons that when we talk about recycling at all, which involves melting the plastic into, oh, I'm getting a notification that my internet is unstable. Can you still hear me?
Yes, we can hear you.
Yes.
You did
Perfect.
cut out slightly, but you're back.
Okay, just let me know if there's a problem. I'll just quickly try to check if I'm connected to the right one. I tend to have some internet issue. Yes, it's correct. Sorry about that. So what we think about when we think about recycling is generally what we call mechanical recycling. What that involves is the melting of plastics into new items, but without changing the basic chemical structure of the material. That's where it differs from chemical recycling. At the bottom, you can see the monomer repeat structures of polyethylene and polypropylene. These are two common types of plastics. As you can see, HDPE number 2, LDPE number 4, and PP number 5. The two first are polyethylene, and the second one is polypropylene. A single monomer of these types are ethylene and propylene, and those are examples of olefins. Through a polymerization process involving a catalyst, these monomers can be combined into longer molecular chains that we call polymers, which is another word for plastics. Depolymerization does the exact opposite of this. It starts with the longer chains and it breaks the molecular chains into shorter ones or all the way down back into monomers. So if you then think about the difference between mechanical and chemical recycling, the chemical one changes the basic chemical structure of the plastic itself and transforms it as a material. This represents quite a huge strength, and I'll explain that by starting out with some of the challenges that we have with mechanical recycling. Because different types of plastics have different melting points, it's difficult to mechanically recycle several types of plastics together, at least without significantly reducing their quality. Moreover, there will be some quality reduction with every round of mechanical recycling. Generally, you can count on one hand how many times an item can be mechanically recycled before it starts losing its property. And that could involve, it starts falling apart, it stops being waterproof, it stops having the properties that you want, such as being rigid or being flexible, and so forth. It's even worse when it comes to applications related to food. With the exception of PET, nearly no mechanical recycling allows using the output for anything that involves contact with food. The real magic of chemical recycling relates to these weaknesses of mechanical recycling. Several types of plastics can be handled at the same time. Not all types, but it's much more flexible in that regard. Somewhat more contamination is accepted. And the monomers can be recombined to produce equal grade plastics and thus constitutes a closed loop. This is very, very different from the type of recycling that we've had this far. And if this can be deployed at a large scale, it represents frankly, a revolution when it comes to the handling of plastic waste. Just to sort of relate this to, how we are used to seeing the plastics recycling value chain. This illustrates the entire value chain and highlights how chemical recycling, which is the orange arrow, differs from traditional or mechanical recycling. It sort of expands what we can see as the plastics recycling value chain. So, plastics is oil, it comes from oil. Normally, the oil would be refined, then go into petrochemical facilities, such as olefin crackers. It would then come out as plastics, go to the plastics manufacturer to produce what we sort of call pellets, which is the raw material that's used to produce plastic items.
Donc, on utilise la matière première pour pouvoir donc fabriquer le plastique. Et vous avez des acteurs industriels.
Goes towards collection, or it's landfilled, incinerated, or leaks into nature. So if you look at how the sort of, I guess the colors aren't that easily distinguishable, but the sort of greenish blue at the bottom, after it's been collected, cleaned and sorted, and reprocessed or recycled, with conventional mechanical recycling, this would either go towards the plastics manufacturer because the output of mechanical recycling is generally pellets, so small plastic bullets, basically. If you've seen it, sort of grains that you can pick up rather than a chemical product. Either towards the plastics manufacturer or straight towards brands, retailer, or industrial applications. However, chemical recycling expands this chain, so the end users of this product coming out of a chemical recycling process would be either refineries or petrochemical crackers, or both, in the case that the product is bought by a refinery, further refined, and then sold to a petrochemical actor. What's also important to highlight is that this is the plastics value chain. It doesn't involve the part of the oil products coming out of a refinery that goes towards burning, either as part of energy production towards industrial use, for instance, or home heating, or the part that goes into fuel for vehicles, for instance. But that is absolutely also an output that can be produced from chemical recycling. It's quite, sorry, I should have specified this earlier. It's quite important to also highlight that this type of chemical recycling that I'm talking about is one type of chemical recycling, which I'll get to on the next slide, called pyrolysis. There also exist other types of chemical recycling, such as you have sort of, for instance, chemical depolymerization, where the catalyst is a chemical product. You also have gasification, but then you'll have sort of a slightly different process. So just to specify what I'm talking about here is pyrolysis, which involves depolymerization, so the cutting down of the chains through heating to high temperatures in an oxygen-starved environment. During the past few decades, pyrolysis technology has been adapted for materials containing hydrocarbons that are difficult to destroy. For instance, car tires. It's not a new technology as such. A reason that the technology has gained more traction more recently is a combination between oil prices that hike at more than $100 per barrel and a growing international concern related to problems and challenges associated with plastics pollution. So more sort of as a solution to a problem. The function of a pyrolysis oven or reactor is to convert solid state plastics, so physical plastics, into flammable gas, which, depending upon the end use, may be further treated and refined. So if you think back to the previous slide, it can go into different applications, but the end product is basically part gas, part liquids, and part solid residues. And the solids will generally come out as waste, or there are some applications you can use it for, but it won't be sort of the main end product. The pyrolysis process is in itself relatively robust, and it can accept a variety of heats. As highlighted here, and I'll go more into this in a little bit, it takes primarily HDPE, LDPE, PP, and some PS. So it's not all plastic types, but it's, as I said, much more flexible than mechanical recycling, where you want to adopt only monostream plastics, so a single type of plastics together. The liquid output from the process is a hydrocarbon mixture with a composition that's not very different from crude oil if you don't do anything else with it, which might be used directly as feedstock to a refinery. Raw, untreated, and unrefined pyrolysis oil is a complex chemical product. It can be transported to and further refined in an oil refinery for the purpose of either selling it as diesel, as I mentioned before, or feeding it into an olefin cracker with the aim of producing new, equal-grade plastics. Several pyrolysis technology developers have gone to the step of including a mini refinery as part of the tail end of the pyrolysis process, so as sort of an integral part of their own process. This involves upgrading the pyrolysis oil to diesel or naphtha, which is the sort of corresponding product that you would use to produce new plastics. It's a feedstock for new plastic production. So that would involve upgrading the pyrolysis oil from sort of this complex product towards diesel or naphtha on site. And such upgrade facilities will naturally increase the investment level of the pyrolysis facilities. When it comes to locating chemical recycling in the waste hierarchy, which you're probably familiar with, I would say it's located in somewhere around the recycling or energy recovery section, so the yellow one or the orange one, depending on what is produced, because you can produce towards different end products. Mechanical recycling is clearly preferred to plastics to fuel. So if you produce diesel, then you would rather want to use, if you can use the same plastics to produce new plastics, you would prefer that. However, if you're looking to produce naphtha, a raw material that goes into new plastics production, involving that you're able to produce new food-grade plastics with less of a degradation, and also you're able to take a wider range of feedstock, then mechanical recycling doesn't necessarily compare as well. So again, it's not sort of black and white. It depends a bit on the type of application that you're looking for from chemical recycling or from pyrolysis. It should also be mentioned that it's possible to make process adaptations after the plant has been built. So if you change the catalyst, if the process includes a catalyst towards producing a larger proportion of naphtha compared to diesel, then you can sort of shift the proportion of fuel versus new plastics that you're producing. If you adopt a process that doesn't have this sort of tail end adaptation, then the end product would be pyrolysis oil, which can be fed into various applications. So depending on who you sell it to, it will determine what it becomes. It's important to highlight from this that when it comes to solutions to plastic waste, it's quite often a topic which one solution is the one solution we should adopt. Should it be, should you and this is also often a topic when discussing it in the context of Ghana. I've also previously worked in plastics recycling in Rwanda. Is the best solution to ban plastics? Should you simply reduce it? Is the best solution to expand recycling measures? Is it best to rely on mechanical or chemical recycling? Is it better to expand waste collection infrastructure? Or is it better to design for recyclability so we can keep the current processes for recycling, but design products that are more easily recyclable? This is really a bit of a false dichotomy, because we need all solutions at the same time because the problem is so big. And again, to sort of quote this report that I mentioned before, which is just below the triangle, modeled on their own, no single solution strategies reduce annual leakage of plastic to the ocean, even below 2016 levels by 2050. This means that the potential solutions should be seen as complementary to one another rather than competing. The way we see it, there are clear strengths of processes that can handle mixed, degraded, and contaminated plastics. But often there seems to be quite a sort of clear trade-off with the potential for circularity, if you take incineration, for instance, that has, because it involves burning, it can take all waste, but that is pure energy recovery with no prospects of reusing the material. So it's a difficult trade-off, all plastics. So I wanted to dive a bit more deeply into this because this is really quite a crucial issue also when it comes to the project economics of doing this in a context such as Accra. The quality of the end product, the yield, and the downtime depends on the quality of what goes into the process. Some process adaptations can be made to improve the quality of the end product, but regardless of the process adaptations, the quality it is possible to achieve will be correlated closely with the quality of what goes in. As put by one stakeholder, and this is sort of a bit boldly formulated, if you put crap in, you get crap out. What this means is that of what comes into the process and make sure that it holds a certain standard. This is predominantly due to requirements for the end product and less in terms of requirements for the process itself. In the face of requirements from the off-takers of the end products, the issue of feedstock quality must be approached consciously and carefully. Firstly, not all plastic types are well suited for pyrolysis. This table shows an example of the feedstock polymer content for a pyrolysis process, and it's from a specific technology developer, which is publicly available. Highly wanted materials are polyolefins, so that is polyethylene and polypropylene. Some types of plastics are unwanted, but to some degree accepted, such as polystyrene and polyethylene terephthalate, which is PET. PET is unwanted due to the emissions of oxygen in the pyrolysis process. So as you can see, the process can accept up to 5%. But again, when it sort of comes back to the question of how could this better be handled, PET is quite easily mechanically recycled and can be used for food grade applications. So using it for pyrolysis isn't necessarily the best way of tackling the material. Finally, some types of plastics constitute a significant problem, also in very small amounts, such as polyvinyl chloride. This is because the end product should contain as little chlorine as possible, which constitutes around 40% of the content of PVC. When PVC is melted down and converted to gas, there will be accordingly developed chlorine gas. This is incompatible with the end product quality that pyrolysis facility must meet. So it's really necessary that the chloride level is close to zero. Some adjustments can be made to the process to remove unwanted chemical components, such as chlorides, through, for instance, something called hydrogenation, or you can add chemical to the process for the purpose of binding unwanted compounds. For instance, if you have formation of chlorine gas, this can be reduced by introducing caustic. Grinded limestone can bind unwanted sulfur in the reactor. However, as I mentioned, process adjustments have certain limitations and will not greatly alter the properties of the end product. Thus, it should rather be sort of considered a control mechanism to achieve the desired end quality in combination with a relatively high degree of control over process inputs. In addition to the wanted versus unwanted types of plastic materials, other materials than plastics can be described as a sort of second challenge to dealing with plastics recycling, since usage will expose the material to various types of contamination. So looking at this, one issue is moisture. Water constitutes an issue to the process because energy requirements will go up when water is evaporated during the pyrolysis process, which takes place at a temperature of 400 to 500 degrees Celsius and more. Furthermore, water contains trapped oxygen, which you don't want in the process, because the pyrolysis process, as it described, has to take place under the absence of oxygen. If there is oxygen present, it will mean that the plastic burns rather than becoming transformed into its basic hydrocarbons. The second issue that can be mentioned is, or sort of main category of other contamination, is organic contamination. This includes food waste, soil, etc. While some types of organic contamination don't constitute a challenge in themselves, there are indications that it correlates closely with the prevalence of unwanted chemical components, such as chlorides. Also, the nature of some organic contamination makes it quite difficult to removing a sorting and a pre-treatment process. For instance, because it's stuck to the surface of plastics, such as food oil. This is really something we saw quite a lot of in Accra. You also have the issue of metals, inert materials, for instance, sand and such, which they don't in themselves cause a problem to the process, but it's just left in the reaction chamber as waste that has to be removed. So again, from an economic perspective, it creates a problem for the yield, and might increase downtime because you have to remove the waste from the chamber. Paper, cardboard, other types of material, it's the same. You're not able to produce something of value from it, so you don't want it to come in. And also often they can actually bring unwanted humidity. If you have cardboard that's been lying outside, it's been sucking up rainwater, it's difficult to remove that moisture. It's more difficult to remove the moisture than it is to just remove the cardboard. So this is also something to be aware of. And of course, unwanted chemical elements. Plastic wastes can contain traces of, for instance, sulfur, originating from plastics that are contaminated with sources of sulfur, which would end up in the final product. If you aim to produce diesel, the specifications on sulfur in Europe and also in Ghana are extremely low. And this is really just a requirement that you have to adhere to if you would like to produce this as an end product. This will vary by country. I actually don't know how it is in many other African countries, but I know that quite a few have adopted the ultra low sulfur requirements. Yes, so just finally, as I said, it has to be highlighted that some types of unwanted non-plastic materials, it's not necessarily a problem to the process. It just sort of comes back to the issue of making this economical. The less plastic you have going into the process that comes out as something you can sell, the more difficult it is to reach economic viability. Oh, sorry, and I also forgot to mention that the plastic products might contain composite additives that have basically been added to the items to change their properties. This could be to enhance softness, it could be to enhance durability, it could be sort of chemical stability, flame retardant, and so forth. And this could be, for instance, if you have cable insulation that you don't want to catch fire, it would add some flame retarding chemical substance to it. You also have the presence of bio-based plastics, which can create significant difficulties, unfortunately, if they're introduced to pyrolysis process, because they contain long alkanes with heavy contents of chlorides, which you really don't want into the process, as I mentioned. These are just some examples of products that should be avoided due to their content of composite additives. And then finally, there are some other properties of the plastic feedstock than their polymer type, which is the composite additives, as I mentioned, and also the shape and related properties of materials going into the process that can affect the efficiency and performance. For instance, if you have flexible plastics, if you have a lot of film, needless to say, if you've sort of ever tried to fill a waste bin of film, you have to really sort of push it down. It's quite, it takes up a lot of space. So it has more surface, lower weight than rigid materials, which makes them more prone to contamination. If you have sort of thin film of plastic and you dip it in organic contamination, it doesn't take that much contamination before the contamination exceeds the weight of the plastic. Again, the flexible types of plastics can be difficult to handle from sort of, just material perspective. It's difficult to shred, it's very light, it has a lower density, and this is the same with expanded types of plastics like styrofoam. And it creates capacity limitations. It's just sort of physically difficult to work with. The lower density potentially increases logistical costs of transportation, storage of feedstock. It makes sorting procedures more difficult. And finally, if you have a high variation in plastic types, you know, so not plastic types, sort of plastic in variation in material shapes. So a variation between rigid, flexibles, expanded, and so forth. It can make the automated parts of the process, including, for instance, pretreatment, a bit difficult because it's difficult to adapt to the various needs of the feedstock stream. To simplify a bit then, and take a step back with regards to what this requires from trying to establish a venture within pyrolysis, the objective of establishing a process to ensure that good enough plastic feedstock quality is fed into the plant will include removing anything that is not plastic. So inerts, organics, textiles, metal, and so forth. It will involve removing unwanted types of plastics. This includes especially PVC and some PET, and removing moisture, which is a huge problem to the process as well. What does this mean in practice? At the collection stage, measures can be made, such as partial or full source separation. This is often not done in low or lower middle income countries, but some smaller collection adaptations that make a large difference can be adapted. For instance, separating only organics will make the other fractions much less contaminated and much more dry. But this is really a little bit sort of, you know, especially if you're relying on existing waste management infrastructure, it's a bit out of the hands of actors such as us, and relies more on municipalities, the waste management companies, and so forth. At the sorting stage, after you have done the collection, it's mainly possible to remove unwanted items, while a pre-treatment or cleaning, if you will, procedure would be predominantly focused on remaining contaminants, such as organics that are stuck to the wanted types of plastics, as well as inerts, such as sand. While a pre-treatment procedure will need to be highly automized to reach any scale, the sorting procedure may be more or less manual depending on cost factors. In middle-income countries, it would be much more sensible to rely more on manual sorting, so by hand, than for instance in Norway, where labor costs are very high. For the mechanical sorting, there are a number of principles utilized, including gravity, centrifugal forces, air currents, heat, demolition, cutting, press force, and magnetism. Several types of mechanical equipment utilizing these principles can be applied and will directly and indirectly affect quality. This includes, for instance, screening units like drum screens or star screens. These are all sort of waste management terminology, so it's okay if you don't know what it is, but we're actually publishing a report that goes a lot more into detail about these types of equipment as well. It can include wind shifters, also called air separators, ballistic separators, shredders, balers, etc. The operating principle for cleaning systems include friction with or without the use of water, chemicals, which would have to be used in combination with water, heat, and so forth. If you introduce water to the cleaning process for the purpose of using it for a pyrolysis process later on, you make things quite difficult for yourself because, as I've been highlighting several times, we don't want moisture to come into the process. If you wash with water, you add a whole bunch of moisture that you have to remove later on, which requires a lot of electricity through the means of dryers. And also you create the problem of what to do with the water from the process. And this basically requires a sort of separate wastewater management facility, which is very costly. For that reason, we spent quite a lot of time looking at dry cleaning solutions. which is really interesting, but that means that there are higher requirements to the quality of what comes into the process. So the cleaning process itself can remove somewhat less contaminants than a cleaning process that involves water. The operating principle for dry cleaning systems is a combination of friction generated by the movements and gravity forces induced by means of rotating impellers or drums. And this sort of illustration is just a generic illustration of how sort of a dry cleaning step-by-step process would look, including a grinder, grinding or shredder, sort of basically cutting up the plastic pieces into very small pieces. So this has to be after all the manual sorting because it's very difficult to tackle. They're very small and uniform pieces of plastics with your hands, quite obviously. And then you would have the sort of dry cleaning, the dry cleaning unit itself, a discharge cyclone, a dust silo, and also an output for the desired plastics. Oh, sorry. A solution to this issue of plastics quality is likely a combination between supply chain interface requirements, improved sorting procedures, and the introduction of a cleaning process, preferably dry cleaning. This slide relates to the introduction of interfaces to improve quality. Sorry, there's an extra preposition in the headline. But this exemplifies the Ghana collection process, where you would have a multitude of various sources, including the informal sector. You would have collection from established waste management companies, maybe some institutions, and utilizing various steps of sorting and reception. You could set requirements where starting in sort of the other end and calculating yourself back in terms of what would be the requirements at each step, it's possible to ensure that you have a consistent quality going into the plant. And this, again, it comes down to how do you sort of establish large-scale industrial processes in an industry where this is less common and hasn't been implemented until now. Moving on to the work that we've done in Accra, Ghana, which will sort of make a lot of what I've been talking about a lot more concrete. Our objective, as I mentioned, is to combat plastic pollution in an economically sustainable way. This involves that it doesn't require major public infrastructure improvements, because if a prerequisite for a solution you're trying to implement requires that all the waste collection is done and all the collection involves sorting at source, you're making things very difficult for yourself. Another prerequisite is that it's scalable and replicable, and also that it's large scale. As you can see in some of these pictures, plastic pollution is a huge problem in Accra, and it's not unique to the city. It's really, I think the only largest city I've been to in Africa where there wasn't much plastic pollution is Kigali, where there is none at all. But as you can see, and as also illustrated by the sort of top left picture, it's not just an environmental problem. So what this picture shows is drainage holes where during the rainy season or sort of during heavy rain, this construction is supposed to lead the water away from the streets and out of the city. If it becomes clogged with plastics, it means that the water can't escape, which causes flooding. Also, on a more general basis, it means that you get a lot of sort of still standing water, which is breeding ground for mosquitoes that carry all kinds of diseases. What we hope to do, and have been working to do so far, is to develop a model for self-financing collection through the transformation of these plastics into a product of value. You can really divide this project up into sort of three key parts that are quite distinct and have traditionally not had that much to do with one another. So the first aspect is that of waste management. And this is a lot of what I've been talking about in terms of the quality of the plastics coming in, is the challenge of bridging waste management, where you generally deal with heterogeneous material. It's quite difficult material, and bridging that into a much more sort of standardized traditional industrial process, such as petrochemicals. That is the second aspect of this type of project, involving process technology. And here the main costs will be relating to, sort of traditional industrial costs, utility, land lease, people working at the plants, power costs, and so forth. And the final part is that of commercialization. How do you produce something that someone wants to buy? And how do you get enough money for that product to finance the operations? Starting with the first aspect, Accra has a quite complex waste management value chain, where you have various sources such as markets, small shops, households, warehouses, industrial actors, office buildings. And the collection is also done by a variety of actors, both formal and informal. And this is really quite common in middle-income countries, that you have a relatively large informal waste management sector that tends to handle the majority of recycling, because they collect specifically plastics or other recyclable materials, as opposed to general waste management companies that will handle all waste. Then you'll have a number of repetition. It's illustrated once here, but it may be several times, of local transportation and reception. And this will generally be done by either the same actor if they have the capacity for it, or another actor. So for instance, if you have a person who collects recyclables, who doesn't have the money to invest in a van to transport the plastics to another place, or doesn't have the land to compile the plastics, that will create some opportunities for other people, transporters, aggregators, middlemen. There's a lot of terms for these functions, which means that it's a complex but also a really quite well coordinated value chain. Oh, sorry, I just want to. And to just make this a bit more concrete in terms of who I'm talking about. To the left, you can see two pictures of the sort of much more formalized waste management sector. You have the larger waste management trucks, these belonging to Zoomline, which is one of the larger waste management companies in Ghana. And you have the waste sorting facilities. Here on the top, you can see the conveyor belts and the manual sorting. In addition to this, there's a lot of equipment that I also just mentioned. On the middle and the bottom, you can
Au
see
milieu, en bas, vous avez une site qu'on les appelle.
Which takes care of collection in a lot of the areas that aren't accessible by the larger trucks, in a lot of underserved areas, and basically complements a lot of the sort of larger scale waste collection. Then you also have the waste pickers, who collect plastics or other recyclables only. And here are some pictures of some of the participants of the pilot project that we did. We did two pilot studies that I'll get back to. The way we see it, the key to developing a viable feedstock supply is utilizing both the formal and the informal waste management. If you look at just sort of the pictures on the bottom, I'm sorry, it's a bit wordy. Should maybe have updated that. But the primary source of plastic feedstock for a pyrolysis plant, the way we see it in Accra, would, to begin with, be the established waste management plants. This is because it takes time to scale up sort of new collection. And a lot of the waste that comes into this plant is actually suitable for pyrolysis. And the alternative use of it is on some of this material coming out of the general waste management plants. It involves the fact that it may incentivize broader collection overall of general waste, which sort of addresses a complementary but slightly different problem in middle-income countries, which is inadequate coverage of just sort of the collection purely, not to begin talking about the recycling aspect of it. You then have the collection through other existing streams, over time potentially working with waste management companies to encourage sorting at source, collecting from businesses, markets, institutions, and so forth. also working with the informal sector involves directly cleaning up the environment and reducing pollution while achieving social impact through job creation. And this is quite important. I think most people working in waste management in Africa and elsewhere would agree that solutions to waste management really has to involve the informal sector because they play such a huge role in solving this problem and are really a huge resource if you can find a way to leverage their competencies. And finally, other sources may involve technological solutions in terms of collecting from rivers and the ocean. This wouldn't bring the necessary scale. It's sort of a smaller source, but it contributes to cleaning up plastics from the environment. And the objective over time here, coming back to the issue of plastics quality, is to shift the proportion received from each source over time towards collecting it closer and closer to the source, which means, fewer steps, less costs in the, transportation piling up of the plastics. And also it means that the plastics hopefully would be cleaner because, if it's already thrown into the bin together with organics, it will already be relatively contaminated by the time you get it out. This approach to feedstock collection has been tested and confirmed through 2 targeted pilot studies. So we did one study at the 2 main waste management plants in Accra, which lasted over 5 weeks and were finalized in December 2019. This was really quite a pioneering pilot in conducting practical operational optimization of sorting methods at existing waste management plants. So not infrastructure specifically built for extracting this type of plastics, but built for another purpose. And testing whether whether it was possible to alter some of the sorting procedures to extract the types of plastics suitable for pyrolysis specifically. What we concluded was that collecting 30 tons per day, which is sort of the the minimum threshold of what would be viable for a pyrolysis plant, is considered achievable, and raising it to 60 tons per day, which really seems to be the minimum to get any economical scale of a pyrolysis plant, is viewed as feasible over time. So in terms of volumes, it's doable. When it comes to quality, the analysis showed that the plastics need further treatment. Again, coming back to everything I've been describing in terms of the plastics quality comes out of the analyses that were done following these 2 pilots. And here the main problems were elevated levels of organic material, sulfides and chlorides. In terms of costs, the cost of collection were relatively low, and the main challenge concerns the cost of pretreatment and or further sorting to enable a more affordable pretreatment solution. The second pilot was a collection point pilot that was implemented in collaboration with the Accra Metropolitan Assembly, so the local authorities, which aimed to incentivize the informal sector workers to collect specifically plastics that we would be interested in for a pyrolysis plant and deliver that plastics at sort of defined collection points. In addition to that, it was a more sort of holistic pilot that was carried out to understand the responsiveness and dynamics of the informal sector when sort of introducing this very new fraction of plastics. It's really quite common today that no recyclers accept just sort of mixed plastics. It's always, payment by type, by quality and so forth. But what we tried to test was, we'll accept all plastics at this cost per kilo, or sorry, at this price per kilo. In addition to the work that was done on establishing the available quantity and quality, and also should mention the quality from the informal sector pilot was much better than from the mixed waste sorting pilot, but still not satisfactory. So some pretreatment is also needed for this fraction. We also did a mapping of EHS, so environment, health and safety, and human rights risks. And I won't talk at length about this, but just sort of summarize that, when working with vulnerable populations and with informal and precarious working situations, it's just really important that you assess how to safeguard human rights, environment, health and safety considerations, and that you consider both positive and negative impacts. And some of the areas that we really looked into quite in depth involved EHS risks, physical risk, use of PPEs, personal protective equipment, whether people have health insurance, is it possible to get medical treatment if necessary? The risk of child labor and labor rights, which is also definitely a risk and should be managed accordingly. And finally, fair compensation. If you pay per kilo of plastics, you need to make sure that you're not violating labor laws and making sure that people get a decent salary, even though they don't get paid per hour. So we did quite sort of in-depth analysis on this as well. And we saw that it was very rare that the participants didn't collect at a rate which allowed not earning Ghana's minimum wage requirements. So in that regard, their economic rights appear quite well safeguarded under the model that we investigated. Offtake considerations, moving to sort of the final of these, 3 parts of the project. Offtake considerations are closely related to the other described factors, plus geographical specificity. The end markets that you're targeting will depend on the product. And again, coming back to sort of whether you're aiming to produce a product for the oil industry that with the purpose of producing diesel for vehicles, or whether you're aiming to produce, a sort of more general product that can be refined further, or producing naphtha that goes into the petrochemical industry, will sort of, it will also be determined by where you're operating. And a quite important aspect of doing a project like this in Ghana is that no local off-takers on naphtha exist. And this is because there isn't a sort of well-developed petrochemical industry in Ghana or any other African countries, with the exception of Nigeria and South Africa. This is quite central because it means that if you have an ambition of producing plastics from this end product, you would have to export it to a location that is able to produce plastics from it. If there's an ambition to export it to Europe, producing plastics, some other challenges come into play, such as environmental considerations. Does it make sense to put this on a ship to sail it to Western Europe just to avoid burning it in Ghana? And also economic considerations. Export is expensive, so exporting to Europe would require a quite significant premium on the end product. Local offtake prospects involve pockets of opportunities from the local specificities of the Ghanaian market. So now we're talking about most probably diesel, but also other sort of hydrocarbon products that can be sold on the local market. Most prominently, competing products are imported, and the Ghana Chamber of Bulk Oil Distributors operates with a benchmark premium. And that premium was $112 per ton of diesel that was imported per September 2020 last year. And this might not sort of tell you a lot, but it's a quite, if that can be, which isn't guaranteed, but if that can be transformed into an additional revenue, if you sort of, have that cost benefit from producing it locally, then that's quite a significant addition, which you wouldn't get if you were to export it. Also, taxes and levies represent a significant proportion of price to end consumers, which creates the prospects for the government to incentivize the local sale and additional revenue prospects for projects like this. Although producing diesel isn't as circular as producing naphtha for the production of new plastics, I think it's quite important to sort of highlight that the objective we've had all along is to demonstrate the economic viability of valorizing plastic waste and ensure the economically viable and large-scale collection. And again, the process itself can be adapted along the way if something changes. For instance, if it becomes possible to get a large premium on the European market for for naphtha produced also outside of Europe. This is just to sort of illustrate the value chain for diesel, which highlights that taxes and levies constitute a large proportion of the price of diesel. And you'll receive these slides later. It's more just for reference. To summarize what all this means, reaching economic viability is challenging in a setting such as Ghana, because the high costs are not covered by the revenue prospects from the product value only. When it comes to the feedstock collection aspect and the waste management aspect, having to pay for plastic waste, having to pay for the collection and logistics costs, and having to conduct further pre-treatment as indicated by the pilots. This involves paying, and I'm just going to find this. It involves a cost of, on average, around $210 per ton of plastics that is fed into the plant. This is very different from the situation of wanting to do a similar project in Europe, for instance, where conducive policies contribute to either not really having to pay for plastic waste or being paid for it because you're contributing towards the solution. So this is one sort of quite difficult aspect of doing it in Ghana. When it comes to the processing cost, as I mentioned, if you adopt sort of a tail end refinery, you get much higher costs. And we looked into whether a simpler operational setup would enable lowering the cost, for instance, having no catalyst or having no hydrotreatment facility. But simply put, a simpler product also means lower revenues, because then you would produce something that's similar to crude oil, but a bit more difficult. So really sort of, you'd have sort of a large end price discount from it. So it wouldn't really pay off. And in addition, there would be other challenges, such as the product being less stable and the need for refining infrastructure. However, a huge benefit of this would be the lower investment costs. So again, if it's possible to identify local refinement capacity that are able to refine this product into something more usable, it's not to sort of reject that as a possibility, but it is somewhat more difficult. And then finally, on the sort of income side, there's the revenue from sales, which is closely related to the process technology and quality of feedstock material. And the other main determinants are, as I said, the geographical location and the policy environment. Overall, under the current assumptions, the project isn't economically viable in the absence of supporting policies. And this brings me to the next slide, because to answer the question of how to develop best practice action plans for the management of plastic waste, I wanted to touch upon the very important role of policy. Because the reality is that when it comes to tackling all types of plastic waste, or all types of waste for that matter, policies are required for shifting the incentives towards better resource utilization. In the waste management business, value can be created in two ways. Through the value of the material itself, and this is really what's fueling current mechanical recycling. It takes the most valuable fractions and produces something that can finance its collection. And through the provision of a service to solve a problem. And the latter generally requires policy interventions, which is the case in the EU. If you take, just as an example, general waste, you'll have often tipping fees or landfilling fees, which means that you, whenever you bring something to the landfill to dispose of it, you have to pay a fee. If this is the case, you as a waste manager or recycler can charge a fee for handling the waste as a foundation of your business operations, as long as this fee is lower than the alternative costs. So it really sort of shifts a bit how building a business works. And this is just one example of what you'll see everywhere in the waste management business. On this theme, I just wanted to touch upon a policy tool that was discussed quite at length last week, but I just wanted to sort of highlight it here as well to bridge how it's also, it's very closely related to the type of project that we're trying to get up and running. EPR, extended producer responsibility, is an environmental policy approach in which producer's responsibility for a product is extended to the post-consumer stage of a product's life cycle. This is one example of how policy very concretely could contribute towards shifting the economics where it currently looks difficult, such as the one we have. At its core, the purpose of an EPR scheme is shifting the burden of managing the relevant waste streams away from the municipalities and ultimately taxpayers towards the producers by providing a mechanism for securing financing for infrastructure investments and operational costs for necessary collection and treatment. In practice, an EPR scheme on packaging will generally require that each producer pays a fee when introducing packaging to the market that's proportional to the amount of packaging. The fee would then cover all or part of the costs of collection, sorting, and recycling or recovery or disposal of the packaging waste, and may be sort of conducted by the companies themselves or delegated to another company or organization. EPR has proven to be an effective tool to ensure that the political targets are met in a cost-effective way. This especially applies for waste streams where the value of the waste material itself doesn't cover the full cost for collection, separation, and recycling. For middle-income countries, and I'm sure this was discussed last week, unfortunately I couldn't attend that session, but happy to discuss it more. For middle-income countries, there are some specific challenges to implementing EPR that have to be addressed properly. Many middle-income countries have experienced prosperous economic growth in the last decades. This has given way to increasing purchasing power and consumption in the population. But with rapid growth, especially in the big cities, the demand for costly infrastructure escalates. The most leakage of plastics to nature happens by far in middle-income countries. And here some of the main challenges include inadequate waste management infrastructure as a starting point. As I mentioned before, a large informal waste management sector that can make it more complicated to impose changes. And it can also be difficult to establish proper documentation about the producers and their market shares, since custom and trade registers may be insufficiently developed. On the positive side, establishing EPR schemes represents a certain additional benefits for middle-income countries. The most important benefit seems to be that EPR may provide a more viable way of financing important development steps of the waste management sector than any other alternatives. The prevalence of a large informal sector, by definition not regulated and taxed, will be closely related to the difficulties of generating sufficient tax revenues that could fund waste management. So EPR is a way to sort of circumvent that. In Ghana, there is currently an ongoing process for the implementation of EPR, but it's a comprehensive and challenging process because it requires very precise and unambiguous regulation and the capacity to implement it consistently. There is already a plastics tax in place, but the funds haven't been directly directed towards waste management specifically. Hopefully, over time, a system that contributes to financing the collection and management of plastic waste can contribute to making it more viable and easy to introduce solutions that target the plastics problem much more broadly than only the most valuable fractions. In the shorter term, it's also possible to introduce policies that create a premium for the sale of recycled end products through, for instance, waiving applicable taxes and levies, which, as I mentioned just now, are a very large part of the end price of diesel. This has much larger prospects for shifting the project economics than any realistic cost reduction. And finally, considering the nature of this type of project, it would also benefit from more traditional industrial policies, such as special export zones, policies that enable affordable land, utilities, and so forth. I hope I provided some insight into the opportunities and challenges identified for pyrolysis as a potential technological solution to plastic waste in a lower middle income country like Ghana, as well as highlighted some of the key economic considerations for projects like this. We really have, I would say, identified an opportunity for great impact and done much of the groundwork, but key obstacles still remain for reaching commercial viability that we keep on working on. A key component of the work of the foundation also involves a commitment to transparency and openness, and sparking interest and engagement in sort of developing common solutions. So I'm very happy to take any input the listeners may have. And all the findings that I've presented today are actually summarized in reports that either are or will shortly be published on our website. As I mentioned in the introduction, the problem is concrete, but solutions are quite difficult and really involve that technological, social, political, and business factors all work together to find the solutions. No single solution can pull the weight on its own. There's no magic sort of fix it all. But with a multitude of efforts, we really can get closer to solving this immense problem. Thank you.
Thank you so much, Selma. That was wonderful to hear. Everyone, please feel free to send through your questions in the Q&A or in the chat box. In the meantime, there was a comment from Chris White that says, we already have a self-funding model for small-scale pyrolysis developed in South Africa. It has been tested and proven. One of the main issues is that the legislation and compliance costs at the scale in South Africa has led to a few problems. And he's happy to discuss and connect further. Are you happy for us to email through your contact details to him?
Of course, thank you.
Wonderful. In the meantime, I was wondering if you could perhaps expand a bit on the possible contamination in the pyrolysis treatment that you mentioned earlier, just in terms of sort of contamination of either of the waste that's coming in, or whether it's the mix of the waste that is the issue, and things like that.
Yeah, sure. So contamination can be understood as if different things. So as I started out, it can be, the presence of something that, creates a problem to the end product because it's chemically difficult to treat, or it can be something that just lowers the yield. So it constitutes an economic problem, but less of a technical problem, so to speak. In terms of where this issue could come from, it can really be a mix between the different plastic types. If you have elevated degrees of PVC, for instance, and it's not always obvious. So you can take the example.
Selma, you seem to freeze for a minute there. Sorry about that. You cut out.
Okay. Is it back now?
Yes, you're back.
Yes. Okay, perfect. No, so just to sort of briefly summarize, I think it's easy to think about it as, contamination can come from a variety of sources, which could be that you get the wrong types of plastics. It could be that you get the right types of plastics, but there has been something added to the items, as I mentioned, for instance, flame retardants, which makes it more difficult. Or it could be due to the presence of something that's just completely unwanted, such as moisture, organic contamination, or other items such as cardboard and so forth. So I think, where's the contamination coming from? Mainly, if you look at the sourcing of plastics from mixed waste, it's coming from the fact that, if your starting point is mixed waste and you need to sort out the plastics that you want, you can do it either by means of positive sorting, so you sort out what you want, or negative sorting, which means that you sort out what you don't want, and then you end up with what you want, ideally. Both of these approaches are quite difficult if your starting point is mixed waste, because it's mixed, obviously, but it's very dirty. It's often difficult to spot, and it puts quite sort of high requirements of the people doing it. So that being said, it's really also expected that there would be a learning curve in implementing this over time, which you don't really get over sort of the course of a 5-week pilot. But it's it's really the main challenge comes from the fact that this has been mixed in the first place, if that makes sense.
Thank you, Selma. That's great.
I hope it was hopefully also it's if you get the slides afterwards, I'm trying to sort of to map it out.
Thank you. There's been a question in the chat box in the Q&A section that says, thank you for your comprehensive presentation. Could you clarify whether such a plant has been successfully set up and is operational anywhere in Africa or another developing country?
Not at this scale. So there are, as was also mentioned for the South African case, small-scale pyrolysis reactors. that produce generally, I mean, the pyrolysis process can be used to produce, sorry, my dog is making some noise. I don't know if you can hear it, but sorry about that. If you produce pyrolysis oil, you can use that for fueling, for instance, industrial boilers that will have lower quality requirements than diesel used for vehicles. You can also use it to produce electricity. If you don't have as stringent quality requirements for fuels, you could use it as fuel as well, but it's a difficult and unstable product, which contains some things you don't want to sort of burn in the open. That being said, there are a number of small pyrolysis facilities that do operate. There is also one in Ghana. But when it comes to trying to implement something at the sort of scale that we're looking to do it, processing 60 tons of plastics per day, which is really a lot. I'm not familiar with any similar project that has been implemented, especially not producing blend-in quality. It's really also something that's just emerging in Europe and the US as well. So, I mean, again, even though the reactor itself is old and it has existed on a much smaller scale for a long time, this idea of, doing it as a large-scale industrial application, where if you look at the facilities, it really would look more like an oil refinery than it would look like something that sort of comes in a container. That doesn't exist.
Thank you, Selma. There seems to be a slight echo, but there's another question in the chat that says, in your experience in Ghana, how is the plastic waste collected? Are there artisanal collectors and how are they paid?
Artisanal collectors, what I understand by that is waste pickers, or is that incorrect? I'm just to clarify the word.
I would imagine so. Abdullah, I don't know if you want to confirm. Yes, he says.
Yes, perfect, thank you. Yes, so actually, I'll just maybe jump to one of the slides that I had that goes a little bit into detail about this. So, so as you can see, it's collected in a multitude of ways. And I think what's really quite important to highlight is the difference between the actors collecting plastics only and the actors collecting all types of waste, including some plastics as sort of part of that mix. When it comes to the collection of plastics specifically, it's predominantly waste pickers and informal sector workers who do that. And this sort of the stream that tends to follow, and that will often be from, as you can see sort of here, markets, small shops, households, and so forth. Waste pickers collect, anything from household waste. You'll have a lot of the waste in the markets includes the water sachets, sort of the water bags that people drink from. All sort of waste related to sort of general consumption, fish nets and so forth, which is then being brought to other informal sector workers, here termed aggregators. That can also be termed, middlemen. I've heard a lot of terms for it, which is then received by someone who has the capacity to stockpile it. It may be the same actors if it's a waste picker that happens to have the capacity to also perform the transportation and the collection. And it's then being sold onwards to recyclers or processors. At the same time, you also have, as I was saying, the semi-formal actors like the tricycles, Polyethylene, who do the collection from households and also from shops and so forth, who collect the general waste, but sometimes they will sort out the plastics during the collection, so that when they come to the mixed waste management plants, they will have sorted out some of the valuables to be sold onwards, similarly to the waste pickers and the aggregators. Also at the formal waste management plants, there's some sorting happening. So again, you receive sort of a mixed household waste mix, from which they also sort out, some textiles. There's the sorting of PET bottles, also sorting of water sachets, which can be recycled as well. Not very efficiently, but they can be recycled. And also rigid plastics, so HDPE and so And there was one study that was, and which is then also sold onwards to recyclers and processors. And then finally, you have sort of the last, which we didn't touch much upon now, but if the plastic goes to the landfill, you also have waste pickers working at the landfills. And here you'll have, again, sort of the same chain happening, where the waste pickers do the collection, selling it to aggregators or transporters, it being aggregated and then sold to processors or recyclers. So there's no sort of single response to it. But again, the actors that collect recyclables only tend to be informal actors. The one sort of prominent exception is that there's one company, quite small company, that covers one of the Accra is divided into, I think, 10 districts where waste collection happens, which is mandated to different companies. And one of those companies is working to implement sorting at source. So the company itself is collecting recyclables separately for the purpose of recycling. So it's a bit of a complicated answer, but it is a complicated industry.
Thank you, Selma. There's another question in the Q&A box that says, will this methodology apply for any country? I don't know if you want to comment on that a little bit.
Yeah, I think in terms of, so if by methodology you see the sort of approach of tackling the waste management aspect, the processing aspect, and the offtake aspects as sort of individual parts of a whole to be tackled, then yes. I think when it comes to the specific solutions we've been looking at, a lot of it would probably be, replicable to other locations, but there will always be local considerations to be taken into account. For instance, if you have so one example would be if you produce diesel to use as fuel for cars, you're in practice conducting sort of energy recovery, again, going back to this waste hierarchy. Oh, sorry, I just saw the follow-up question. I'll answer that in 1 second. If you have inadequate power production, another way to do energy recovery would be incineration. And there has just been built a major incineration facility in Addis Ababa in Ethiopia, which is highly modern, and as far as I understood it, I'm not an expert on incineration at all, is quite efficient when it comes to utilizing the sort of energy content of the plastic waste as well as all other types of waste. Also, when it comes to the local factors of waste management, I think it's safe to say that in all African countries you'll have quite sort of significant informal sector, but the way it's structured and the role that they play will vary from place to place. So with some reservations, I would say that it could definitely be replicable, and it should be replicable. That was one of the requirements for venturing into this project. But as with everything, you have to just be very conscious of any local adaptations that have to be made. And just to answer to the question of how they're paid, so generally they will be paid in cash. That's just the sort of most accepted form of payment. We also tested during the pilots to some extent, but there were some technical issues with the implementation of mobile money that I'm sure you're quite familiar with. But then that requires that everyone has a mobile money account, everyone has a mobile phone, and that this sort of is set up in a way that's smooth, because something we experienced was the importance of paying people immediately. If you pay, if you make a transaction and you say, I'll make the transfer tonight, that's not really viable, because people want to see that they get the money they're supposed to get, and also if they were planning on spending it on the same day, you can't really have that sort of delay, which was a bit of a challenge. But I think there are some interesting solutions emerging. We also looked into, there's for instance, through blockchain technology, you can trace payments. However, that doesn't solve the final payment interface to the waste pickers as such, because very few people would actually have sort of, a Bitcoin account or whatnot. So, you would still have to make that transaction by means that is accessible to people, where cash and mobile money, I think it's safe to say, is sort of the most viable solutions. Based on weight, yes, per kilo.
Thank you, Selma. There's another question here in the box that says, one more clarification based on your response. You mentioned that this type of venture is starting in Europe and North America. Are there in such locations, are there operational plants? And if so, what is the capacity of these plants?
Yeah, so there are operational plants. The largest capacity I've seen operational is 60 tons per day. So the same size that we're looking at. And there's currently being made installments that are aiming to process up to 100 tons per day that are currently being sort of run in. When it comes to what they produce, it's also a good mix between, and it's quite sort of an interesting distinction between the technology developers who aim to produce sort of a blend in end product, so diesel or naphtha, or to produce pyrolysis oil with the purpose of selling it to an off-taker that's basically sort of willing to process it further and able to process it further. But it's quite interesting, or sort of it's quite important to note that thanks to the policies that exist in Europe and that are also being implemented at the moment, it's, you really see sort of a huge run to implement these types of solutions. There's new projects that I come across almost every day. For companies who are looking to expand chemical recycling processing capacity, and I think it's really quite interesting because it shows, if you're able to create a secondary market for the end product where you get paid more than you would have if you're just basing it on sort of the general commodity market, then suddenly this is a very, very viable solution. But it's, as I've been describing, it is much more complicated. It's not impossible, but it's much more complicated in countries where you don't have those type of policies.
Thank you so much, Selma. I don't see that there is another question here that says, several types of solutions are proposed, transforming plastic waste into building materials, into bitumen for roads, and now there is the solution to produce energy. In the context of some developing countries with limited means and a waste management system that is not performing well, which of these models is the most realistic in terms of cost and benefits? Could we have an idea of the budget to implement the model you presented?
Oof, an idea of the budget. Okay, so to implement this type of solution, you're looking at, depending on the scale, an investment cost of $30 to $50 million. It's a huge investment. So in terms of wanting to do something and sort of doing it incrementally, it's difficult. It requires very large scale investments, which is the same as incineration, which is immensely costly to build. When it comes to solutions like, building, you have sort of tiles, you have the potential of including plastics in roads and so forth. I really see, these are really, in my view, more solutions relating to disposal. Again, looking at sort of the waste hierarchy, because it's sort of, it's a more durable use and it contributes towards taking the plastics out of the environment, but it's a sort of end of life purpose. And there are also a number of challenges related to, including plastics in road production, in the sense that it may sort of get separated out and create issues in microplastics later on. So although these are, in many ways really good solutions and quite interesting to sort of follow, they represent challenges on their own. But from an economic perspective, they're much more viable, as are any type of mechanical recycling solutions, because the facilities required are much smaller. You can start at a much smaller scale. So it's easier to sort of get started, if that answers the question.
Thank you, Selma. Yes, it appears that has answered his question. There's one more question in the Q&A box that says, given the obstacles you outlined in Ghana, what are the next steps for your foundation in terms of bringing this technology to scale?
Yeah, that's a good question. I can't sort of answer that definitely, because we are a bit at sort of crossroads in terms of figuring out how to bring this onwards. And I think, it's quite important to also highlight that, our foundation doesn't have the technology itself. We would have to work with a technology provider who can, take care of basically, providing the reactors and building the plant. So, this type of project is very reliant on working with partners. And there are a lot of components that sort of have to fall into place, including, technology. You have the issue of offtake, you have the issue of financing, and so on. I think some of the most important enablers of this product really relate to what I touched upon towards the end when it comes to the implementation of policy. And that could be either through, and this is probably a much more sort of long-term solution, but through the implementation of extended producer responsibility. Or in the shorter term by granting, a temporary or permanent waiver for taxes and levies. At the same time, we'll keep on working on the cost aspects, trying to sort of see, is it possible to lower the costs in some ways? What other pretreatment options are there? But I think, it's quite safe to say that, and this really relates to coming back to the purpose of the foundation, the project has to be able to sustain itself. Otherwise, it's not sort of a model that enables scalability and replicability in other locations. So it's tough nut to crack, but we're working on it and we're hoping to succeed.
Thank you so much, Selma. Oh, sorry about the echo that seems to be coming through. Sorry about that. I don't see any more questions in the Q&A in the chat, but if anyone has any questions at a later stage, please feel free to send those through to us and we can pass those along. For now, I think we can close off here today. We are trying to end slightly earlier in these sessions just to accommodate everyone's busy schedules and I think a bit of webinar fatigue that's been going around as well. So on behalf of SST and Abdullah, who's here, I'd just like to say thank you so much, Selma, for presenting for us today. It's wonderful to hear about the different opportunities that are available and to hear about the work that was happening in Ghana. And if anyone has any questions, please feel free again to send those through to us. But otherwise, I think we can end here for today.
Thank you all for listening. And also, just as a final comment, as I said, a lot of the findings that I've presented today will have been or will be published in public reports that will come up on our website. So I'll also share that with Tara and can send a link through to the new reports when they come out. So the most recent ones were specifically on pretreatments, on local offtake, and also on extended producer responsibility in Ghana.
Selma, thank you very much and congratulations. Superb talk.
Thank you. And thank you all for listening.
Thank you, Selma. On behalf of the Abidjan Convention and the SST, I think I can talk on behalf of Tani. And maybe we learned a lot from you today.
It's a lot of information, I'm sorry.
No, it was good and always very captivated by what you were presenting. And maybe if you don't mind sharing your presentation, it could help.
I would.
Thanks a lot, and we are looking forward to experiment your pilot project in the Abidjan Convention region maybe one day. But 50, how much you said? $50 million?
Yes.
It's a budget.
It's a big budget, yes.
Okay, thank you.
It's a large problem, so we need large-scale solutions.
Thank you so much, everyone. We will have another session on Thursday afternoon where we will be having a panel discussing building a market for used plastic through enterprise development. You should receive an email about that in the coming day or two. So please tune in and join us for that as well. In the meantime, thank you again, Selma. It was wonderful. And we'll pass along the document once it's been published, and the slides will be available along with the upload. So I think we'll close off here today, everyone. Thanks so much, and I hope you all have a wonderful afternoon.